Hello, welcome to the course Understanding Electricity and Electronic Devices by Q in Motion. Today, we're going to talk about PNP transistors. On previous class, we studied NPN transistors and we saw how those could be used as switches. The load or the device where we want to switch on and off goes connected between positive and the collector of the transistor. So the transistor acts as a switch to the negative side of the power supply. Today, we're going to talk about the PNP transistor and some of its applications. Here on the right, you see the symbol of a PNP transistor. The first thing you might notice is that the arrow is pointing in instead of pointing out, right? Remember, on the NPN transistor, the terminal with the arrow, and on this one too, it was signaling the emitter of the transistor. Only here on the PNP, it's pointing into the transistor, and in the NPN, it was pointing out of the transistor. So the PNP transistor works exactly the same as the NPN transistor, only that the polarities are reversed. If you recall, in the NPN transistor, the emitter was usually connected to the negative side of the power supply. Here on the PNP, this is going to be connected to the positive side of the supply. Also on the NPN transistor, the base had to be positive, more positive than the emitter for the transistor to turn on. Here it is the opposite. The base has to be more negative than the emitter for the transistor to turn on. So if we were to put this in a circuit, it would be a circuit like this pretty much, right? So the emitter goes connected to the positive side of the supply, and the base current comes out of the transistor to ground, right? To the negative side of the supply. And the collector current comes out of the transistor, again, also to the negative side of the supply. Again, the model for the PNP transistor is the same as the NPN transistor. I have here on the top right, the NPN transistor model, right? So we had the base and the diode to the emitter, and then the base current was controlling the collector current, right, which was beta times bigger. Now on the PNP transistor, we have the same thing, only the polarity of the diode is reversed, right? So the base current flows out of the base, right? On the NPN, it flowed into the base, and now it flows out of the base. And the same with the collector current, right? The collector current flowed into the transistor, and now it's flowing out of the transistor. Okay, so other than that, it is exactly the same. The base current is still controlling the collector current, and the collector current is beta, or the DC current gain, or HFE times bigger than the base current. Okay, and beta again can be a couple of hundreds. Let's see some applications of the PNP transistor. One of them is to switch the positive side of the supply, okay? So this is a circuit that is very similar to what we saw on the first example, right? So the positive side of the supply goes to the emitter, and the collector goes to the load, or the device that we want to switch. When this controller pulls current from the base and to ground, this transistor is gonna be supplying collector current to the load here, okay? Producing the voltage at the collector to increase. This is usually called a sourcing output, or a PNP output sometimes, right? And that means that the load goes connected to ground permanently on one side, and the output of the device, right? Assuming this is some other kind of device, the output of the device is switching the positive side of the supply. The ones we studied on the previous class is called a sinking output, right? Because one terminal of the load was permanently connected to the positive side of the supply, and the other side was switching to the negative side of the supply with an NPN transistor. So that is sometimes called an NPN output or a sinking output. Now, we may have a little bit of a problem here, right? Because if this thing is powered with 24 volts, the only way of turning off the transistor is to have a voltage at the base that is close to the 24 volts, right? Because as soon as this is 0.7 volts below the 24 volts, we're going to have current flowing from the base and causing the transistor, the PNP transistor, to turn on, okay? So if this controller is putting out 3.3 volts, it will not be able to turn off this transistor. So sometimes the PNP transistor is going to be used in combination with an NPN to pull current from the base. So this circuit is going to be slightly modified into something like this, okay? So how does this work? Basically, the controller is turning on and off this NPN transistor. When this transistor turns on, it's going to pull current from the base, right? And produce a PNP to turn on. Now, when the controller turns off this transistor, there's no current flowing from the base, and therefore there's no current flowing through the collector. But sometimes to ensure that there is actually no current flowing through the base, another resistor is added here, right? Because even if this transistor is off, it is never 100% off. It may have some microamps of leakage here, especially at high temperatures. So by providing another resistor here, we are providing a path for the leakage current of this transistor through this other resistor. And so it's not coming from the base. There's still going to be a little bit from the base, but it's going to be greatly reduced, but because this resistor is going to be providing most of it. All right. Now, let's see another application of the PNP transistors used in combination with the NPN, right? So we have Q1 here is a PNP transistor, Q3 is another PNP transistor, and Q2 and Q4 are NPNs. Connected in between here, we have a motor, a DC motor. Remember, a DC motor, you can control the direction by controlling the polarity. So let's say if it is positive on this side and negative on this side, it turns clockwise. And if it is negative on this side and positive over here, it will turn counterclockwise. Okay, so how does this work? If we turn on Q1 and Q4, right, we're providing a path for the current to go through Q1. We're providing positive on this side of the motor, and then we're providing negative on this side of the motor, and the current goes through Q4 to ground. So under our assumptions, that will cause the motor to turn clockwise. Now, if we turn off Q1 and Q4 and turn on Q3 and Q2, we are providing a path for the current to flow through the motor in the opposite direction, because now positive is going to be on the right side of the motor and negative on the left side. And according to our assumptions, that would make the motor to turn counterclockwise. All right. So how do we control these transistors? Well, we will have some kind of controller, some kind of device that's going to be the brains of the system, if you want. That's going to be controlling the base of Q2 and the base of Q4. Okay, so if we want to turn clockwise, the controller will turn on Q4. Okay, now we still have to turn on Q1. And how do we do that? Well, we can resort to the same trick as we used in the previous slide, right? In this case, when we turn on Q2, we have the base of Q3 connected over here, right? So this Q2, on top of providing negative polarity to this side of the motor, is also pulling current from the base of Q3 and therefore causing Q3 to turn on, and Q3 is going to be providing positive to this side of the motor. And of course, we can do the same with Q1 and Q4, right? So by adding a resistor here, when we turn on Q4, it will turn on Q1 as well. Now the controller has to ensure that Q2 and Q4 are not going to be turned on at the same time. If the controller turns on Q2 and Q4, Q2 will also turn on Q3 and Q4 will also turn on Q1. So we will have a short circuit because we will have a conduction path from the positive side of the supply through Q1, which is turned on, and Q2 and straight to ground, and also from Q3 through Q4 and straight to ground. So it is very important in this configuration to have a good control of what's happening on these transistors, okay? So let's do a quick review of what we saw today, right? We studied PNP transistors, and they work just as NPN, but with their polarities reversed. And PNP transistors are often used along with NPN for applications requiring sourcing current to the load. They're also used in H bridges for motor drivers. Okay, that is all for today, and we'll see you next class with another type of transistors, which are called MOSFETs. Thank you, bye-bye.